Hey everyone. So in this video, I'd like to talk about applying the distributive law to a few different kinds of examples. So the distributive law says that if we have some quantity and we multiply it to a sum or maybe a difference, well, we can distribute that multiplication across each term. Right, so this is really the same as saying, well, let's take A and multiply it with B, and let's add that with A multiplied to C. And so that's the distributive law, and typically the distributive law is used to simplify expressions where we see this kind of multiplication to a sum or a difference. And so where does simplification appear? Well, simplifying sometimes appears when we're trying to solve equations or inequalities. So the distributive law can really be used to help us solve these equations and inequalities. So let's take look at a few different examples of that. So let's solve this equation. And so here, to solve this equation, we want to isolate that w variable. And it's kind of hard to do that when one of the w variables is tucked inside of these parentheses here. And so let's simplify this expression on the right, and let's do so by distributing this multiplication of 4 across the parentheses. So right, we do this and we get an equivalent expression. But this one will not have those parentheses there. That w will be a little bit more free to work with. And so we get 4 times 2w plus 4 times 5. And we still have that minus 3w. And we can write this as 8w plus 20 minus 3w as the expression on the right, and then we still have this 35 on the left. And then we can simplify this even further by combining the like terms in the expression on the right. So here this 8w and this minus 3w, these are like terms, and so we can actually add them together and get a simpler equivalent expression. This is 35 still on the left. Right, that left expression is very separate from the one on the right. Can't put those together. But here on the right, we can combine those like terms of 8w and 3w minus 3w to get 5w plus 20. So what can we do from here? Well, here we want to get that w alone, and well, it's being multiplied by 5 and then added with 20. So let's peel off that layer of addition by 20 by subtracting 20 from both sides. Right, so minus 20. And so if I subtract 20 from both sides, well, we get 35 minus 20, that's 15. And then here, if I have 5w plus 20, and then it has this minus 20 also, well then those plus 20 and minus 20s are going to cancel out, and we're just left with 5w. And then we can divide both sides, undo this multiplication by 5 to w with division by 5, and we end up with w is equal to 3. So this is the solution to our equation. This is the number that makes our equation true, and I encourage you to check that it makes our original equation true. And here, in this example, we had to use the distributive law to really get to this final answer. So this example looks a little bit more involved than the previous one. But if you're feeling confident and want to give it a try first, I definitely recommend it. So here, the first thing I want to point out is that if we're trying to simplify this expression, each expression, the ultimate goal is get that w variable alone. Well, here I just want to point out that we can't perform this 9 minus 3. It doesn't follow order of operations to do that subtraction before the multiplication or the parentheses. So just one big pitfall that you want to avoid in this kind of example. So if we want to get that w variable isolated, well, we'll need to simplify each expression and get those w variables outside of the parentheses. And so let's begin by distributing that 4 across that difference there, and then here I'm going to distribute that minus 3 across this difference here. And so we get 4 times 2. So I'm not going to write out the full distribution this time, all the little steps. I'm just going to write this as 4 times 2. And that's going to be 4 times negative 3w is negative 12w, right? We're subtracting 12w. And then on the right side, well, we still have this 9, but then that minus 3 is getting distributed to give us, well, minus 3 times 2w is minus 6w. And then that minus 3 times that negative 1, well, that will give us this plus 3. And so the left expression I can't do much with on its own. The right expression we can, right? We have some like terms. We have this 9 and this 3, these constant terms that we can truly add together. You know, we can't combine these unlike terms of 9 and negative 6w, right? These are unlike terms we can't simplify by adding these in any sensible way. So the 9 plus 3, that gives us 12. And then we have minus 6w. And so to solve this equation, I want to move all of the w's onto one side, all the w terms onto one side of the equation. Well, I can move them away from the left side of the equation by adding 12w to both sides. Right, if these two expressions were equivalent to begin with, if we're not equivalent to begin with, if they represented the same quantity to begin with, you know, they were truly equal, then adding 12w to the left side will give me the same result as adding 12w to the right side. They'll still be equal after adding those 12w's. Well, 8 minus 12w plus 12w, whatever number 12w represents, if I subtract it and then add it, those are going to undo each other. I'm just going to get left with 8 on the left. And then on the right, well, we have 12, we have minus 6w plus 12w. These are like terms here. And we can add them together as, well, minus 6 plus 12, that's plus 6 sets of w. Now to get that w alone, I want to subtract away 12 from both sides. And so we subtract away all the constant terms away to get that 6w alone. And so 8 minus 12, that's negative 4. 12 plus 6w minus 12, well, 12 minus 12 is 0, and we still have that 6w. And then the last step is to divide out that multiplication, right? So undo that multiplication of 6 with division by 6. And so on the right we have w, our variable, completely isolated. On the left, well, we've got a fraction, and typically we want to reduce the fraction if there's any common factors between the numerator and the denominator. And well, I see that the numerator and denominator are both divisible by 2, so I'm going to write this as, I'm going to divide that 2 out and get negative 2 over 3. So this is the solution to our equation. This is the value for w that makes the left side equal to the right side if we plug it into our original equation. So this is the solution here. So in this next example, I have an inequality, and solving inequalities is really no different than solving equations. We just, except for the one little detail that if we multiply or divide both sides of the inequality by a negative number, or divide both sides by a negative number, then we'll have to reverse or flip that inequality sign. But here, you know, we'll still want to approach this the same way. We want to simplify the left side, simplify the right side, and get that variable alone. So how do we simplify the left side? Well, we can distribute. Right, and how do we simplify the right side? Well, here, maybe let's talk about that in a moment. Let's do the left side first. This is 2n, and then 5 times 4 is 20, so plus 20. 5 times minus 3n, that's going to be minus 15n. So that's the left side. It's going to be greater than or equal to 5, and then here, 5 minus 3 minus 2n as a group. Now we've seen this before, right? Here we've seen that if we subtract a group in parentheses, this is really the same as subtracting each term in the group, right? Minus 3 and then minus negative 2n comes out to be plus 2n. Right, so we've seen this before. Another way you can see this is if we view this as one set of, in parentheses, 3 minus 2n. Right? Anything's the same as taking it and multiplying it with 1. Really, this is the same as our expression here. So 5 minus 3 minus 2n in a group is the same as 5 minus 1 times 3 minus 2n. So this is one way people like to really relate what we've seen before to what we've seen now with the distributive law. Right, so how can we view simplifying this with the distributive law? You can kind of imagine distributing that minus 1 across. Right, so here we end up with, this is going to be the same thing. 5 minus, I'm going to write this as 1 times 3 minus 2n. That's the same as 5 minus, well, negative 3 times, or sorry, negative 1 times 3 is negative 3, so 5 minus 3. And then negative 1 times negative 2n, well, that's plus 2n. So either way works. So if you want to view this as distributing a negative 1 across each term, that's perfectly fine. I personally like to see it as subtracting each term, and that's also valid too. Okay, but anyways, let's write that here. So we have 5 minus 3 plus 2n. And so we can further simplify these two expressions by combining the like terms. We've got 2n and minus 15n. And we've also got, what else do we have here? We have 5 and minus 3. These are like terms as well. So this comes out to be 20, and then 2n minus 15n, well, that's minus 13n. It's greater than or equal to 2 plus 2n. And now we want to get that n variable alone, so I'm going to try and get all those n variables on the same side. I'm going to add 13n to both sides, and you can subtract 2n from both sides to get all the n's on the left. I'm just going to add 13n to both sides because I like dealing with the positive coefficients as opposed to negative, right? If I subtract away 2n from both sides, we get minus 15n on the left. But if we add 13n to both sides, we get plus 15n on the right, which is the same idea. Anyways, this gives us 20 is greater than or equal to 2 plus 15n. And let's subtract away the constant terms. This is minus 2 from both sides to get that 15n and that n variable closer to being alone. This is 18 is greater than or equal to 15n, right? If I have 2 plus 15n minus 2, well, the 2 and the minus 2 cancel out. And then the last step is to divide out 15 from both sides to get that n variable alone. And dividing by a positive number doesn't really need to reverse the inequality sign, or it doesn't. So here we end up with just n on the right. We've got that greater than or equal to sign facing away from n. And then 18 over 15, there's a common factor in the numerator and denominator of 3. So I can divide that out. And I will get, well, 18 divided by 3 is 6. 15 divided by 3 is 5. So n, 6 over 5 is greater than or equal to n. So this is the solution set to our inequality. And maybe you like more concrete decimal values. I think maybe that'll look a little bit more explicit or a little more familiar. 6 over 5. It goes in 1 time and 1/5 left over, which is 2 out of 10, right? So this is 1.2. It's greater than or equal to n. Right? So here, 5 goes into 6 one whole time, and it's got 1 left over, 1 out of 5 left over, and 1 out of 5 is 0.2. So this is another way we can see this same inequality. And it's usually easier to view an inequality when it's the variables on the left. So we can flip around this whole inequality sign or expression that says n is less than or equal to 1.2. Right? These are all the same. But I think maybe the one on the right is the easiest to understand. Right? So here if I have my inequality, my number line, I want to make sense of the solutions here to this inequality. Well, here we're saying that at 1.2, that value is included in the solution set, and all the numbers that are less than that are also included in the solution set. Maybe it'll be clear if I use colors. So this is a picture of all the numbers on our number line that make this inequality true. So let's do one last example here. It says Risa bought a sweater and pants together for $108. And she bought shoes that cost twice as much as the sweater. And so if we let C represent the cost of the pants, we want to write expressions for each of the different costs below. And as usual, I encourage you to try these different examples out yourself. I feel like this is a really good one to try yourself first. I think it's expression building can be quite challenging, but it's useful to get some practice. Okay, so here, we're letting C represent the cost of the pants. Right, so here, what information do we have about the pants and its cost? Well, we don't know this, and we're not trying to figure it out. We're just trying to write some expressions for the cost of the sweater, the cost of the shoes, and then the total cost, the total amount that Risa spent. So let's take this one at a time. So here it says that Risa bought the sweater and the pants together for $108. And so one way you can kind of look at this is that, well, if we let S be the cost of the sweater, well, then we know that S plus C, the cost of the pants, is going to equal $108. And we can subtract away C from both sides. We're looking for the cost of the sweater. We want an expression for this cost of the sweater. And so if I get that sweater cost alone, we'll have an expression for it, right? So if I subtract away C from both sides, we get S is equal to 108 minus C. So this is an expression here, 108 minus C. That's an expression for the cost of the sweater. And it should make sense, right? If we paid, or if Risa paid $108 for both of these things together, well, if I take away the cost of the pants, I'll just be left with the cost of the sweater. So $108 minus the cost of the pants is what she paid for the sweater. So S is equal to $108 minus the cost of the pants minus C. So this is an expression for the cost of the sweater. What about the cost of the shoes? How do we get the cost of the shoes? Well, it says, then she bought shoes that cost twice as much as the sweater. Maybe I'll write this out in words instead of symbols. I think maybe this will be a little bit more clear. So this statement is saying that the shoes purchased, the cost of the shoes, is equal to twice the cost of the sweater. Well, here we know the cost of the sweater, right? The cost of the sweater is, well, it's given by this expression, 108 minus C. And so the shoes, these are, well, 2 times, twice means double, right? 2 times 108 minus C. This is an expression for the cost of the shoes. I don't know if I wrote it above, but I meant to say write an expression for each of these costs and simplify that expression. So let's simplify this expression. Here there's a distribution we can apply, right? This is 2 times a difference. This is equal to, well, 2 times 108, this is 216, and then minus 2 times C. This is cost of the shoes. And the last thing we're asked to write an expression for and simplifies is the total amount Risa spent. So Risa bought, and so total spent, well, she bought pants plus the sweater plus the shoes, right? At least the cost of these things. And so, okay, we have an expression for the pants, right? The pants we said were given by that variable C. The sweater, well, this was given by the expression 108 minus C. And then the shoes we have here is 216 minus 2c. So if we add these three quantities together, we get the total amount spent. And here, when we combine some like terms, namely this c and this minus 2c, those really cancel out. And we're just left with 108 there, plus 216 minus 2c. And that should make sense, right? Because we said earlier, that the cost of the pants and the sweater together comes out to be $108. And that's what we're really saying here. When we add those first two quantities, we get 108. And then lastly, 108 plus 216, those like terms can be added together, and that gives us 324. And then we still have this minus 2c. So this is an expression for the total amount spent.